Time travel, the very thought sends shivers down our spines. Imagine witnessing historical events firsthand or glimpsing the future that awaits us. For centuries, humans have been captivated by the idea of manipulating time. From ancient myths to modern science fiction, the desire to journey through time is deeply ingrained in our collective imagination. But is time travel merely a fantasy, or could it one day become a reality? The concept of time travel is not just the stuff of fiction. Scientists have been grappling with the possibilities and paradoxes for decades. To understand how time travel might be possible, we need to delve into the mind-bending world of modern physics, where time is not the steadfast, unchanging entity we perceive it to be. Our journey begins with Albert Einstein, the genius who revolutionized our understanding of space and time. His groundbreaking ideas have forever changed the way we perceive the universe. His theory of relativity, published in the early 20th century, shattered the Newtonian notion of absolute time. Before Einstein, time was thought to be the same for everyone, everywhere. Einstein revealed that time is not a universal constant. Instead, it is relative, meaning it can be stretched and compressed. Imagine two identical clocks, one stationary and one moving. One clock remains on Earth, while the other embarks on a high-speed journey through space. As the spaceship accelerates, something extraordinary happens to time. According to Einstein, the clock in motion will tick slower than the stationary clock. This effect becomes more pronounced as the speed increases. This phenomenon, known as time dilation, arises because time is intertwined with space, forming a unified fabric called space-time. The very fabric of reality bends and stretches. The faster an object moves through space, the slower time passes for it relative to a stationary observer. This means that astronauts traveling at high speeds age more slowly than people on Earth. This mind-boggling concept has been experimentally verified countless times and forms the foundation of our understanding of the cosmos. It challenges our perceptions and opens up new possibilities for exploring the universe. To grasp the concept of time dilation, let's consider a fascinating thought experiment involving a high-speed train traveling at an incredible velocity. Imagine two observers, one standing still on a platform and the other traveling inside a train moving at near the speed of light. The observer on the platform watches the train zoom by in a blur, and both observers have identical clocks synchronized to the same time. From the perspective of the platform observer, time appears to slow down significantly on the moving train. The clock on the train seems to tick much slower than their own clock on the platform. Meanwhile, the observer inside the train experiences time as if it were normal, with no noticeable change. To them, their clock ticks at its usual pace, and it's the platform clock that appears to be running slow, almost as if time is dragging. This intriguing discrepancy in time perception arises because the speed of light remains constant for all observers, regardless of their relative motion or speed. To reconcile this fundamental fact with the differing perspectives of the platform and train observers, time itself must stretch or contract, a phenomenon known as time dilation. Time dilation might seem like a bizarre and abstract consequence of physics, but it has real-world implications that affect our daily lives. For instance, GPS satellites orbiting Earth experience time dilation due to their incredibly high speeds and the effects of gravity. Engineers must account for this effect meticulously to ensure accurate positioning and navigation on the ground, making sure our GPS systems work flawlessly. Einstein's theory of relativity suggests that traveling to the future is indeed possible, at least in principle. This groundbreaking idea has fascinated scientists and dreamers alike for over a century. The faster we travel through space, the slower time passes for us relative to those who remain stationary. This phenomenon, known as time dilation, is a key aspect of Einstein's theory. If we could achieve speeds approaching the speed of light, we could effectively fast forward into the future. This means that while only a few years might pass for the traveler, decades or even centuries could pass on Earth. Imagine embarking on a spaceship capable of traveling at 99.99% the speed of light. The experience would be unlike anything humanity has ever known. You set off on a journey to a star system located 100 light-years away. The vastness of space would unfold before you, a silent witness to your incredible voyage. From your perspective, the trip might only take a few years due to time dilation. The stars would blur into streaks of light as you hurtle through the cosmos. However, when you return to Earth, you would find that centuries have passed. The world you once knew would be transformed beyond recognition. While traveling to the future in this manner is theoretically possible, the technological hurdles are immense. The challenges we face are not just scientific, but also engineering marvels waiting to be achieved. Achieving such incredible speeds would require colossal amounts of energy and advanced propulsion systems that are currently beyond our reach. The dream of time travel remains a tantalizing possibility, urging us to push the boundaries of what we know and what we can achieve.